Hi, and welcome to Chapter 4, Section 1. So Chapter 4 is all about experimental design. We want to figure out how can we set up a study effectively and appropriately, how can we choose people to be in our study. So today we start off with how to choose those people. Sampling methods. We've talked about before how when we do studies, we don't want to ask every single person in the population to be in our study because that would be a lot of effort. If you're talking about doing a study on everyone in the US, how are you going to get everyone in the US to participate in whatever study or whatever survey you're trying to do? That's a lot of work. There is something that does happen. It's called the census, and it's happening this year. Every 10 years, the United States does a census about everyone living in the US. You've probably seen a bunch of ads for them trying to get people to answer their questionnaires. And so the US is using this information to plan out, how they build their infrastructure, what kind of supports and programs they need to support all the people within the US. So this is super important information that probably wouldn't be as accurate if they were just to use a sample. And so that's why the census, because it's so much work, is only done every 10 years, because it's also very costly. All the people that they have to send out to try to get every single person to answer it for those people who are lazy and don't answer it. So that's why when people do studies or when researchers do studies, we want to just look at a smaller sample. That way it doesn't cost as much, it's not as much work, easier to deal with in general. So in order to choose this smaller group of people from our population, we want to be able to use random sampling in order to choose these people, the smaller group. So random sampling is just some sort of process that involves something random. So whether that's like picking names out of a hat or choosing a few people here, a few people there, basically we want to reduce any bias. And you've probably heard of the word bias before. It's not a great thing. And we'll talk about it more later in this video. But we want to make sure that the sample that we get is still representative of the population in general. So we want, if you have a certain mix of ethnicities, you want to have that mix. If you have a certain mix of age groups, you want to have that mix within your sample as well. So there's several different types of random samples that we can make. And depending on the study, some of these types will be better than others. It really depends on the study itself and what your goal is to study, things like that. So the most basic way to do this is called a simple random sample. So it's simple. First of all, though, simple random sample has a lot of syllables, so we're usually going to refer to this as an SRS, so simple random sample. But basically, in a simple random sample, every person within the sample itself, or every person within the population, has an equal chance of being selected to be in the sample. So the easiest way to do this is, if your population is small enough, you could write everybody's name down, put all the names into a hat, and then draw names randomly, like shake up the hat first and then draw names. Now this method is a little bit harder to do when you have a larger population, because with a larger population it takes a lot more effort to write everyone's names down. So instead we can assign everyone in the population a number, because with technology we can use a random number generator to then generate these random numbers to choose our people. So in our class, this process is good, but it's a little bit difficult when our random number generators is our calculators, but our calculators all generate different random numbers. So say like on a test or the AP test, we would get all sorts of different answers, and that's really difficult for grading. So what we use instead is a random number table. All right, so with a random number table, I've included an example here for you. So the way that we're going to assign numbers to people changes just a little bit, depending on how many people you have in total. So let's say we had like 300 people total in our population. We would look at the number of digits corresponding to how many people are in our total. So if we have 300 people in our population, we're going to use 3 digits at a time. So assign everybody in your population a 3-digit number. So like if they were number 1, they would be 001. all the way up to 300. Or you can use like 000, because technically that's a 3-digit number as well, all the way up to 299. And then any numbers that are out of that range, we could just disregard. So as we move through the random number table, then we would look at 3 digits at a time, because we had 3 digits that we were assigning to people's, to correspond to people. So if I go through the table, the first row is the number 614, because that's the first 3 digits that I see. So 614 is not within our range of numbers, so we would skip this number. Then the next number next 3-digit number I see is 242. So whoever is number 242, they would be included in my sample. Then I would keep going down the row. The next number I see is 041, so whoever is number 41 would be included in my sample. Then I see 986, so that's not within my range, so that number gets skipped. So basically, as you use a random number table, you need to specify what numbers you're assigning to people, what numbers you would skip. Let's say instead we had like our school. If our school was the population, we have about 2,600 students in our population. So then we would look at 4 digits at a time. So our numbers would go from like 0001 to 2600, or whatever, however many people there are in our school. And then you would look at 4 digits at a time. So 6142 would be our first number, but again, that's not in our range, so we skip. Then 4204 would be our next number, again, not in our range, so we skip. 1986 would be our next number, that is in our range, so whoever has that number gets chosen for our sample, and we would just continue on through the table until we get as many people as we want to be in our sample. The next type of random sample that we're going to talk about is the stratified random sample. So these next two, the stratified random sample and the cluster random sample, are kind of similar because they start off by grouping your population into categories first. So when we group by category, this could be like by gender, by age group, by location, some sort of like similarities within your population. So these groups that we split them up into are called strata. Specifically for the stratified random samples, the groups are split into strata. Then from each of your strata, you're going to pick a few from each. So let's say we're using our population as all the students at our school. We could split them up by grade level, so 9th, 10th, 11th, 12th grade, so we would have 4 strata. And then we could look at the overall percentage of each of our grade levels. So if there were 30% 9th graders, 25% 10th graders, 25% 11th graders, and 20% seniors, then we can pick our sample according to those percentages. So out of our 9th graders, we would randomly select whatever makes up 30% of our sample size. And then we would pick however many people would make up 25% of sophomores, and then randomly select whatever would make up 25% of our juniors, and then however much 20% of seniors would be to make up the composition of our sample itself. So some benefits to using a stratified random sample is that, first of all, the people in your sample are actually randomly selected, even though we, picked a few from each group, because in that process we have to randomly pick. And then we are also being representative of our population because we are making sure we include a few from each of our categories. That way, in our sample, we know we have a few freshmen, a few sophomores, a few juniors, a few seniors. Versus with a simple random sample, when you randomly pick those people, it might just so happen that you end up with a whole bunch of freshmen and only a few seniors or something like that, just out of luck. So that's why the stratified sometimes is a little bit better because it guarantees that you have a few from each group. The next type of random sample is called a cluster sample. So in a cluster sample, we're still grouping our population by category. So that's where it's similar to the stratified random sample. However, with our groups, we call them clusters instead of strata. So that's what differentiates. But also, when we have grouped our population, then we're going to choose a few clusters to be in our sample. So rather than like choosing a few from each group, we're just choosing a whole group. So if we were to split our school into 9th, 10th, 11th, 12th grade, then our sample might include all of the 9th graders or all of the 11th graders, something like that. But because this would, if we grouped them by grade level, we would end up with such large samples that probably isn't what we want. So instead, we could group maybe by first period classes or something like that. So whatever classroom you end up in your first period class, that would be your cluster. And then we can go through the school and randomly pick clusters. So if we like numbered all the different teachers who had a first period class and then randomly selected those numbers, and those clusters would all be in your sample. So maybe we end up choosing 3 clusters. So you would have 3 classes who would end up being in your sample. So benefits to a cluster sample is that it's still kind of random, less so than a simple random sample or a stratified random sample, but it does make more sense logistically. So as a researcher, imagine having to travel to all these different places, even just like different classrooms. If we're just choosing a few from each classroom, like in a stratified, then you have to go to a lot more places, versus if you're just choosing several classrooms, you just go to those 3 or 4 that you need for your sample. Cluster sample is actually how our district tends to do surveys. So if, at any point in time during the school year, you're required to do some survey, that's because the district has told our school that we need to send this survey out to students or whatever. And these surveys usually are sent out through select high schools or select middle schools, something like that, because the district themselves, as like the researcher, would assign, they would group our whole districts, all the schools in our district, by school, and then they would tell which schools to have done the survey. This is much more convenient than having a few people from each school do a survey, because then you have to send out that survey to those people specifically, because those people are also randomly selected in that stratified form. So it's just logistically a lot more complicated. So cluster is convenient in that way and makes more sense when you're actually doing a research project. If you have budget constraints, things like that, that's why cluster would be used. The next type of random sample is called a systematic random sample. So in systematic, think like there's a system to it, some sort of pattern. So what you want to do is list out all the people in your population, randomly choose a starting point, whether that be like choosing a random number or whatever, and then you're going to choose people to be in your sample based on a fixed periodic interval. What that means is like look for every 7th person or every 20th person or something like that, but following that pattern. Another example could be if you were just looking at all the people walking into the school, you can just survey every 10th person or something like that. The last type of sampling method I want to talk about is the convenience sample. First, let me point out, this is not a random sample. So this is actually bad. You don't actually want to do this. However, it is convenient, like the name says. So in a convenience sample, you're just choosing people to be in your sample that are convenient to you. Examples of convenience samples would be something like if you just looked at the first 20 people to walk into school, or if you had a survey and people were able to choose whether they responded or not. So like think of it as like volunteers who respond to your survey. These things are bad because most of the time, like the first 20 people who walk into a school, they have some sort of similarity amongst them that would affect your data. Or like volunteers, if they choose to respond, it's usually because they have more of an opinion on something. So if it was a survey, that would also skew your results. So the bad thing about convenience samples is that it introduces bias, and we're not going to be representative of the overall population. So let's talk about bias then. You've probably heard of the word bias before, like when we say someone is biased towards something, but basically bias occurs when certain responses are systematically favored over others. So if you have a convenience sample and they're all very, you know, early when they get to school, it's probably because they all take the school bus or something like that, or their parents drop them off and their parents have to go work somewhere, and that's why they come to school so early. So if they all have that similarity in common, they might affect your data because they have that similarity. And so whatever responses they have, it's going to be favored over others. One type of bias that might occur would be called undercoverage. Undercoverage is when part of the population has a reduced chance of being in the sample, like if they were left out. So if we were grouping our students in the school by first period classrooms or something, then anyone who was absent or anyone who's late to school because they weren't in their first period class or something like that, they would be less likely to be in the sample because they weren't there. So that would be considered undercoverage. And this would be bad because, or this would be considered a bias because if all those people who are left out all have some sort of commonality, then when you do take your sample, those responses or that type of response would be left out from your data. Another type of bias is called non-response. So this is when people that were chosen to be in the sample. So you went through the whole process of doing your random selection and the people you chose didn't respond. This happens a lot when people used to do phone surveys because they would pick the people to call or randomly select the people to call using that random process, but then the people don't pick up the phone or they screen their calls, whatever. And so because there's non-response, then it's basically another part of the population or that got left out. And so those responses you wouldn't get to count towards your data, and that affects your overall data. Another type of bias is called response bias. So this just occurs when your questions are bad. So if you're giving a survey and your questions are bad because they're leading people to answer a certain way, or if they're confusing questions to begin with, like filled with too many technical terms or something like that, that affects a survey's outcome. Another example of response bias is when you have self-reported responses. People do lie. So if they're responding to a survey and they're asking people to, report if they've ever committed a crime, that might not be so good because people wouldn't want to actually tell you the truth about that. So these are also biases. And the last type of bias is called the voluntary response bias. So we've talked about already, if you have volunteers, this is not going to be representative of the whole population. So that's why you would end up with voluntary response bias. Also, people who tend to choose to respond usually have more extreme opinions about whatever the subject is. And Yelp is a great example of voluntary response bias. So people who write reviews, these are all volunteers. They have taken their time to tell you about this restaurant or this business, whatever. But those people usually tend to either really love the business or really hate it. So they have many complaints because they had a bad experience, and so now they are taking the time to vent about it on Yelp. Or they are friends with the owners or whatever, had a great experience, and so they want to take the time to write a really good review. With the ones in between who, had a just okay, decent experience, they're less likely to actually go and take the time to write a review about it. So that's why with voluntary response bias, you tend to get more of the extremes in responses. All right, so we've talked a lot about different ways to pick people, what might happen if you don't get the people that you picked, or if you chose people badly to be in your sample. So we're going to continue on in this chapter to design the rest of our study, whether it's an experiment or anything else, so that we can, get the overall design. Thanks for watching. Bye.